Okay, hi students in cyber chemistry. Today we're going to talk about scientific notation. Now, scientific notation is probably something that you've talked about before. You probably even covered scientific notation in either a math or a science class prior to your arrival in my class, but we're going to go over it real quick just as a reminder, and we're also going to infuse significant figures into it because those two things work together. So let's take a look at our first slide. So as you can see, it says scientific notation is a way of expressing real numbers that are either too large or too small to be written conveniently in decimal form. So what we normally write is called decimal form. When we have a really large number or a really small number, we're going to write it in scientific notation to save us the effort of writing a bunch of zeros or writing a really small decimal. So we adjust the numbers so that it's easier for us to write and to communicate to others. When you write a number in scientific notation, it always takes this form where there's a number out in front, and then there's times 10, and then an exponent. So this is important. This number that's out in front has to be somewhere between 1 and 9. Now, it can also have a decimal point. So it could be 1.0 or 1.5 or 1.2. Same thing on the other end, 9.1, 9.3, 9.7. The only thing it can't be is a 0, and it can't be a 10. So it has to be a digit, a single digit, between 1 and 9 to the left of the decimal. The last part here is the exponent. The exponent is going to have a negative value if you're talking about a decimal number, so 0.05. That would have a negative exponent. But it would have a positive exponent if we're talking about a really large number, a number greater than 1. So if we were talking about the number 5 million, that would have a positive exponent. Okay, so what we're going to do on this slide is we're going to practice with 4 basic examples here. So in letter A, you have the number 12,509 seconds. So remembering, of course, that the decimal place can only have 1 digit to the left of it, we're going to have to move that decimal place from this position, where it is right now, up to here. So between the 1 and the 2. So when we write this number in scientific form, we're going to get 1.2509 times 10. And now let's look. 1, 2, 3, 4 spaces I moved it. So the number of spaces that you move the decimal place becomes the exponent. And then, of course, we don't want to forget our unit. Now, I mentioned significant figures. That should not change as you go through this process. So this number right here, 12,509, we would count in this direction, 1, 2, 3, 4, 5. So this has 5 significant figures. And our answer here, now it's a decimal, so we have to count in this direction, 1, 2, 3, 4, 5. We still have 5 significant figures. So our final answer is going to be 1.2509 times 10 to the 4th seconds. Letter B. To start off, the decimal point is over here. When we're done, the decimal point has to be between the 1 and the 3 because we can only have one number, and it can't be a 0, one number to the left of that decimal point. So we're going to change this number to 1.302 times 10. Now, we moved the decimal place 2 spots. So we're going to have a 2 up here. Let's keep our unit. In terms of significant figures, this has a decimal place. So we count in this direction. 1, 2, 3, 4. So we have 4 significant figures. And here, you can see we also have 4 significant figures. 1, 2, 3, 4. This is our final answer. In letter C, we have a decimal, so a number that is less than 1. Right now, the decimal point is here. We need to move it so that there's 1 digit to the left of the decimal that's not a 0. So that means it's going to end up right here in between the 5 and this 0 on the right side. So we're going to rewrite this number as 5.002 times 10, and now we move the decimal place the other way, so 2 spots, -2, keep the unit of grams. This number, 0.05002, has 1, 2, 3, 4 significant figures. Our answer has 1, 2, 3, 4 significant figures. Finally, in our last example down here, we have the number 0.0300. When we're done moving the decimal point, it needs to end up right here so that you have one non-zero to the left of the decimal point. So we're going to write this number as 3.00 times 10. Now I moved it one spot, 2 spots over. So this will also have a -2. And of course, we're going to keep the unit of meters. Now, some of you might be asking, why did I bother writing these zeros here? Why didn't I just cut it off at the 3? And it has to do with significant figures. So if you look, this number, the original number, we have a decimal place, so we're going to count in this direction from right to left. So we have 1, 2, 3 significant figures. We stop counting right here. If I just had the 3, that would only have 1 significant figure. So I have to keep these 2 zeros here so that I maintain the 3 significant figures that I need. We're going to try this in some practice problems in an assignment. So if you don't quite get it here, you're going to try it on your own, and then of course I'll answer any questions that you might have. Let's take a look at going the opposite direction. So if we look at, I apologize for this, if we look at the screen here, we have 4 new examples. This time, we're going from scientific notation into regular notation. So, if we notice, we have 1.400 times 10 to the third. The third means that we're going to move our decimal place 3 spots. Now, a positive exponent means we should end up with a really large number, and that's what we're going to get here. So this is going to be the number 1,400. Now, some of you might be convinced that this is your final answer, but there's a problem here. Notice that 1.400 has 4 significant figures. 1, 2, 3, 4. Right now, our answer only has how many significant figures? 2. So this doesn't work. So what we have to do in order to get 4 significant figures is we have to place that decimal point here. And I know some of you might think, well, that's not really important. That's not really relevant. But it is when we're trying to maintain significant figures. By putting that decimal point here, we now count in this direction, and we wind up with 4 significant figures, just like we had over here. Now we could add on our unit of seconds. In letter B, we have 2.5 times 10 to the 5th. So, 2, 5. Now, if we have 10 to the 5th, moving it 1 spot takes care of 1 of those. Now I have to move it 4 more spots, so I need to add on 4 zeros. So this becomes the number 250,000. We want to keep our unit of milliliters. Looking at significant figures, this has 2 significant figures. This has no decimal point, so we count in this direction from left to right. And this has 2 significant figures. Okay, let's take a look at letter C. Notice this time we have a negative exponent. So that means our answer should end up being a decimal number that is less than 1. So I'm going to write 412. Right now the decimal point is here, right, between the 4 and the 1. But now we're going to move it 2 spots, and we're going to move it so that it ends up being a decimal. So this is 1 spot. Now I need to move it a 2nd spot, so I'm going to put the decimal point here. Just place that there. So moving the decimal spot 2 spots to the left gives us 0.04. That makes sense because we had a negative exponent, so our answer should be a decimal. The last thing that I want to mention, this number, 4.12, has 1, 2, 3 significant figures. This answer that we came up with has 1, 2, 3 significant figures. Finally, in letter D, we have 3.00 times 10 to the negative 6th. So we're going to move it so that we have a decimal. We're going to move that decimal to the left side. So I'm going to move it once past the 3, and then I need 5 zeros after that. So here's the decimal place, 1, 2, 3, 4, 5. Then I have my 3, and I'm going to keep those 2 zeros at the end. So let's take a look at this number. We have 1, 2, 3, or 1, 2, 3 significant figures here. We have 1, 2, 3 significant figures here. We have a unit of meters. The nice part about scientific notation is you can always go back, especially if you're going in this direction, and check your answer. So if I wanted to put this back into scientific notation, I would move the decimal place 1, 2, 3, 4, 5, 6 spots. Here I would move it 1, 2 spots. That's right. Here I would move it 5 spots. So 1, 2, 3, 4, 5. That would be correct. Here I would move it 3 spots. 1, 2, 3. Okay, so again, try the practice assignment on scientific notation, including the calculations at the bottom. Remember the rules for significant figures when you're trying to do those calculations. I'll be back with another video going over that assignment. I hope everyone has a nice day. See you soon.